Hi, I'm Steve Welly, founder of Backwoods Solar Electric Systems. This is our solar electric introduction videotape. We're going to cover most of the information from our catalog about how to put a system together, but with a lot more details and pictures to make it easier to understand. It's not really a technical guide, but more of an introduction for people who aren't familiar with this type of electric power. We're going to visit some families who've been living with independent solar electric power for quite a few years and see what they've done in their homes and hear their comments about it. And we're also going to talk about some important ways to keep the cost down on solar electric power usage and to make the whole thing work a little better. Finally, we'll look at a lot of the equipment that's listed in our catalog and that we're using here and others are using on the tape, and talk about how to select it and make the choices and how to take care of it and how to get the very best use from all of the equipment. When we built this home, we found that we were 2 miles from the closest power lines, and the estimates were to charge about $24,000 just to bring the lines up to connect to the house before we even start using electricity. So we found it was a lot more economical, and in fact the only choice we had at the time was to make our own electricity. Back then solar panels were just first coming on the market for individuals to purchase. Windmills were fairly popular, and we put up a windmill along with our solar panels. So for our own home and Backwoods solar electric business today, we use about 85% of our power from the solar electric power, and the remaining 15% comes from the windmill and mostly the engine generator in the winter when we get snow for several weeks straight with no sunshine at all. When we first built the home in 1978 and put the first solar panels and windmill on top of our tower, it attracted so much interest that our hobby soon became a business, and we started our first catalog selling solar equipment to other people in remote home building sites. In the years since we started, we've expanded our original catalog 16 times, each time adding information as well as new products to teach the user of solar power how to build their system most economically and most effectively. When you're starting to plan a renewable energy system, there are basically 3 sources of natural or renewable energy available to you. One is solar-generated electricity, the second would be wind-generated electricity, and the third is hydropower, small hydro generator for the individual home. I'd like to say that hydropower is the most economical, and if you have the situation described on our hydro tape, even a small stream, say a foot wide and several inches deep, going downhill more than 30 or 40 feet of elevation change over your property, you should investigate first the possibility of putting in a hydroelectric generator. Most people, however, don't have hydro and usually don't have a very good wind site. Solar energy is by far the most popular because it works anywhere, it's the easiest to install, and the most durable with the least maintenance. Wind power is often used to supplement solar in areas where you have a good wind speed, because then you have energy coming in whether it's sunny and calm or windy and in a storm. You have more types of weather that can be beneficial to your energy system. No matter what source you use for your energy, it's essential to understand that you do have a limited amount of energy. If you have water power, there's only so much water going by, and solar electric panels are rather expensive. There's only so many square feet of sun that you're going to be able to collect, and depending on your climate you may have more or less hours of sun on a particular day. So the most important aspect that makes these energy systems work is to use it in a way that makes it go the farthest. If you can use a light that gives you the same quality and quantity of light and uses only a quarter as much power, then you can use 4 of those lights or use the light 4 times longer on a given amount of energy. That means you have more energy to do other things, run refrigerators, freezers, ceiling fans, TV, stereo, computers, whatever. Whatever it is, you can do a lot more with the same energy if you're very careful in every instance to use that energy as efficiently and conservatively as possible. Particularly with solar generated electricity, the power stored in batteries is very important because the sun doesn't shine at night and it doesn't even shine with full brightness every day. Therefore, you have to store energy in batteries so that you can use it 24 hours a day whenever you need to. Again, that storage is of a limited size. The less energy you use to do the same job, the longer you can go on the storage between sunny days, and the better your system will work. And finally, there is a cost involved. Solar electric modules are fairly expensive, and they are coming down in price, but very slowly. So you'll have a much lower cost for your system also if you design with conservation in mind, using appliances that will take the least power to do the same job and not waste any of your energy. The cost of a solar electric system is pretty much proportional to the amount of energy you need to use. In the beginning of our catalog, we have several examples, starting with number 1, the very smallest and simplest and lowest cost, all the way through larger and larger scale, describing what the lifestyle requirement is, the equipment that might be required, and the total cost that would be associated with that purchase. This will also vary with the area that you live in. If you're in the Southwest where almost all the days are sunny, you'll need less equipment for the same level of performance. If you live in the Northwest or on the coast where it's foggy and overcast much of the time, and particularly in the winter, it takes a lot more equipment to have the same performance that is shown in those examples. The examples actually are written for our area, which is not a very high sun area. Another factor in the north areas in Northern America is the seasonal variation between summer and winter. You get a lot more sun, longer days, more hours of sun, more clear days in the summertime than you do in the winter. So there's a lot more energy available to you in the summer than in the winter from a solar electric power system. Let's look at each component of a solar electric system and draw out just what's needed to put together a complete system for a home. Of course, the first part is the solar electric module. This is the basis that makes it all possible. These things came on the market and became available about 1980, but they were used for 30 years or more before that on satellites. And the durability and reliability of the solar electric cell or photovoltaic cell became proven long before they were made into a product that we use today. They're called photovoltaic technically because photo means light and voltaic is electricity, light into electricity. So it's a photovoltaic cell, or we can just call it a solar electric cell to distinguish it from a water heating panel, which is also more often called a solar panel. These are called modules, made up of many cells. Actually, the cells are a little easier to see in this one here, where they're round and have a white background, so it's very clear to see the individual cells. Each of these cells makes about a half a volt. You may be familiar with the fact that we're usually charging 12 or 24 volt or more battery packs, so a lot of cells are put together in series to build up the voltage needed. In most of these panels, we have 4 rows of 9 cells, so there's 36 total cells in each of these panels. So they're capable of putting out up to 18 volts, which is what's necessary to charge a battery. The individual solar cell is actually a very thin wafer-like material, glass-like. It's a very thin crystal structure of silicon, which is basically what glass is made of. Though the actual cell is very, very thin, an enlarged view of how it's constructed would show that there is a division in the center of this very thin wafer, where the silicon is doped with different materials on each side of the center division. Most commonly used are boron and phosphorus today. What happens is light rays, you can actually think of them as particles, photons, coming down into the cell, enter the cell, go through to the bottom where they excite or bounce around the electrons making up the silicon crystal. Some of these electrons bounce up through that center barrier into the upper half of the wafer disk, and the barrier is what they call a diode. In other words, it's a one-way valve, like a turnstile. They cannot get back to the bottom. So as sunlight shines into this cell, we accumulate lots of electrons on the top and a shortage of electrons in the bottom part of this thin wafer. The reason you often see a grid pattern of lines like this across the top of the solar panel is to make connection and draw those electrons off the top. The bottom is connected by a complete continuous plating of metal because no light has to pass through the bottom. But of course in the top we can't block the light entering into this cell, so we make a spread pattern of very thin electrical traces that doesn't block the light but still covers the entire surface of the cell for the purpose of picking up the electricity from every portion of it. We'll look at compare the brands and these various differences in types of the solar modules later toward the end of the tape. But now the important thing is to realize that these things, without any moving parts, without any fuel, without any pollution, and without any maintenance, generate electricity for our home system, and that's the basis of what makes this work. In a home power application, we generally use more than one solar module, since each one is rated around 50 to 100 watts, and home power systems usually have anywhere from 300 to 1,000 or several thousand watts of solar modules connected. A group of solar modules together, which may be in one or several physical groupings, is called a solar array. This diagram shows an array made up of 8 modules. The modules on each group are wired together, and then the groups themselves are wired together in some sort of junction box or terminal strip to connect to a larger wire carrying the power into the battery room. These modules may be mounted on the roof of a house in an area where there is a forest and too many shadows for most locations on the ground. In areas with clear exposure to the sun, the 8 modules, or 16 in this case, can be mounted on a pole out in the yard. Wiring is combined in a box on the underside of the modules on the pole. The power from all the solar modules combined goes into the utility room or battery area, usually in the house or a utility building. Goes first to a charge control and then into the batteries. Now the batteries are really the heart of your power system. They provide electricity to you 24 hours a day. The source, of course, does not produce electricity at night when the sun doesn't shine or when they're covered with snow. So batteries are usually sized such that they can carry the household load for 2 to 3 days, at least in the northern areas, and perhaps less in the southwest where there's a lot more sunshine. The charge control and meters, their primary purpose is to prevent overcharge to the battery. It senses when the batteries have absorbed all the power that they are able to, and it shuts off the power coming in from the solar modules to the battery. The charge control has some other secondary functions. Often, most of the ones we sell have meters so that the owner will know what's happening, keep an eye on the fact that it is charging, how much it's charged up on a given day. Some of them have lights to indicate when the batteries are full. Some have alarms or buzzers to call your attention to the fact of if the battery should become over full or over discharge. But the charge control cannot prevent you from over discharging your batteries. That's really the job of the owner. It can simply let you see what's going on so that you can keep up with it, just like the gas gauge in an automobile lets you know before you run out of gas so that you can take appropriate action. There you have a complete system for changing sunlight into electricity, stored in a battery, ready for you to use. Not so complicated, is it? Notice that in these diagrams we're only showing one line, showing the connection or relationship between the parts rather than the actual two wires that you would use, a plus and a minus wire, or this actually a wiring diagram with all the details. I did want to point out the fact that we have a main fuse between major components. The important thing for safety is to always have a fuse between the battery and any wire connected, and that fuse would be in the positive wire. The battery stores energy that's been collected over a long period of time, so there's quite a bit of energy in the battery, just like the gas in your gas tank. And if there were a fault in the wiring somewhere outside of the battery and all that energy were released at once, it would get the wires quite hot and become a fire hazard. Putting the proper fuse or circuit breaker always between the battery and other equipment can save you from those hazards, and it's really a required thing to put a fuse or circuit breaker on any wire connected to the positive of the battery. If you're going to meet national building codes, they also want you to put a fuse between the solar modules and the charge control. The solar modules generate DC direct current, and batteries store DC direct current. There are two kinds of electricity you may have heard of. Maybe you don't understand it. It's not really critical to at this point. But there is DC direct current, which is most often used at low voltage, although it doesn't have to be. Usually 12 volts, 24 volts, sometimes 48 volts. And then there's AC, alternating current, usually used at 120 volts or 240 volts. DC is the type of current used in vehicles, campers, boats, and it's low voltage. AC is the standard current that you find from the utilities used in household outlets, lights, and typical appliances that you plug into the wall. It happens that solar modules generate DC and batteries store DC. So that's what we're starting with, and we convert some of it to AC for household uses. To use DC power, once again we put a main fuse because we're connecting from the battery out where we want it to be protected and safe, and we would go into a series of circuit breakers which could be then wired as circuits to DC outlets, 12-volt lights, appliances, the type of things you'd find in travel trailers or recreational vehicles. But more and more now, we would also add a device called an inverter. The inverter changes DC power to typical AC household power, usually 120 volts, although some people use 240 volts for special appliances, tools, very deep well pumps, etc. But normally we just use 120 volts AC, standard household power like you would find in an outlet, and it goes into a household breaker box which distributes the power to your wires and lights and outlets in the home. You can use both of these in the same home. Sometimes DC is more efficient. There are some appliances that take a lot less power, that are designed to take less power so that they can be used in boats and camp trailers and so on. And so we might use those to save power. But for the most case, AC, regular household appliances are more convenient, less costly, more available, and more suitable for use. So the inverter is a very important part of the power system that provides AC for regular household power. The inverter is connected to the battery with a very heavy cable because it uses a lot of power, and again, the safety fuse on anything connected to the battery. And the last component we might find in a power system would be an engine generator connected to a battery charger. Now an engine and generator is the type of thing like a Honda generator, or you push a button and start up an engine and it generates AC power, the same type that you can plug in your appliances to. So this generator puts out AC power which can go directly to your household breaker when it's used. It also runs through a battery charger, which is just the opposite of an inverter. It takes the AC, changes it back to DC so that you can charge the battery. and it puts this power into the battery when it's running, again through a fuse, since you are connecting something to the battery. A generator is very useful because there may be times when you need more power than you have designed or purchased solar modules for, such as when you have visitors or when you're doing a construction project, adding on to the house, something like that. And also in the winter, if you have times in the northern areas where it snows for 2 or 3 weeks and you don't see the sun at all, you can still run the generator a couple hours a day, make up for that lost power. So you have complete control, and you're not really limited to a given amount of power should you decide to start the generator and create more. And to simplify this process a little further, since the inverter and battery chargers functions are similar but opposite, they are available now as a single combined unit. And all these fuses and circuit breakers and meters and charge control are available as one other combined unit. This one's called a power center, and this one's called a standby inverter. It stands by because if a generator is needed, it becomes your battery charger as well. All automatic, all one piece of equipment. Now we'll visit with some of the folks using solar energy that we toured this winter, and look briefly at the equipment used in each of these homes and talk to the owners about what it does for their lifestyle, how much power they have, how conservative they have to be with it. This home, built by Dwayne and Lisa Michael in Plains, Montana, has only 2 or 3 solar modules, a very small system visible just above the snow at the bottom left corner of the house. Because they only have a couple of solar modules at this time, and because of the extensive snow in northern Montana, they do use a generator once a week for their major appliances, pumping water and supplementary battery charging. But the rest of the week, with their lights and other appliances, they run completely from the batteries and inverter system. They have a small 800-watt inverter. This is the power system inside of the house in the basement. There's a small charge control right in the center, made for RV use actually, or modest homes with less than 4 solar modules, and it's installed right next to their regular home breaker box. Directly below the equipment on the wall is a plywood box containing the 4 golf cart batteries. This box has a tight-fitting lid and a vent pipe for any battery gases that should be contained in the box. It goes up and vents them to the outside. Next to the battery box is a conventional automotive type battery charger that runs supplemental charge into the batteries whenever their generator is running. This is Dwayne and Lisa Michael's house, and they moved in here how long ago?
About 4 years ago.
And there wasn't any power here at that time?
No.
How far away is are the power lines here?
Coming in the main road, it's about 2 miles, and I've been given an estimate of $40,000 or $50,000.
That's one of the highest.
Yeah, we have a neighbor that's right 2 properties next door that has power that would let us maybe go through his place, but then it'd still be $12,000 or $14,000. We've got an estimate on that.
So you decided you looked into and studied solar yourself and decided what you needed to do?
Yeah, well, when we moved, we left a busy worldly life, and we moved here, and we thought that we'd come and get power through the neighbor for sure, because we've never lived without power before from the grid, I guess. And after being without power, we've just kind of slowly grown into being used to it. Now we don't want to get power down here for nothing, even if they brought it to us for no charge, because we've gotten used to the system that we have.
You built your own system, put it together, built that battery box.
Right.
And it's a fairly small system as far as they go.
Right.
But it seems to do most of what you need. What are your main applications?
We started out with the 4 batteries, and and then we've added a couple solar panels, and we want to go to another solar panel or two this summer. And that's mainly for the winter time. The summertime, we don't ever need any more
And
panels.
plenty with 2 panels. What do you use it for?
We use it for the water pump. Is the main concern is we get a cistern downstairs that's 350 gallons, and we fill that up once a week, and the water pump, the 12-volt pump, pumps it throughout the house.
The cistern is filled while the generator is running.
Exactly.
Well,
We run the generator once a week for about 4 or 5 hours, and we'll run everything off of that vacuum. We'll do our laundry and fill up our cistern, and then we'll be...
and it charges the batteries a little bit.
It can charge the batteries too. During the winter, we'll charge the batteries with it. So everything's done at that time, and then the rest of the week, the batteries hold up just fine.
There's the 2 of you and 2 kids,
The kids,
usually.
right?
Do you run your lights at night?
We have some propane lights, but we're trying to use the battery lights more since we have the power to use
A
them.
lot easier and safer.
Yeah, right.
And so you're able to have as much light as you want to
Yes.
have with that many batteries.
Right. We conserve on certain things, but like the lighting, you don't ever really have to worry about that. What we'll conserve on is the water if we have to, but even then, it's not that big of a deal. You know, we can't use a washing machine during the time when we don't have the generator going, but if we have a load, we just start it up and use it. So it's convenient.
Yeah, we're not as primitive as a lot of our friends that haven't been here think, you know.
Yeah.
Yeah,
We have a porch light, you know, we
Because
have...
you do have power, and they think,
We
well,
have
they
power,
don't have
right?
power.
Exactly. We have a sister that she come and stayed for a couple of days, and after writing letters, she thought this was going to be something else, and she walks in the house, and after a year or 2 days, she goes, "Well, this isn't so bad. I could do this." 6 months out of the year with the sun, we can run anything we want all day long because it's constantly charging the batteries. And on a sunny day during the summer, it may only be charging for an hour, and the rest is just kind of wasted. So you might as well use it if you can, use the power. I didn't know what to expect, but it's been a lot nicer than not. We're really comfortable with the system. It's really nice.
We've grown with our system, you know.
Yeah.
When we came here, we were just there, basically, and so as time's going on, we can appreciate what we're able to do, you know. Like you said, be able to plug in a blender or a hand mixer instead of doing it all by my arm, you know. Occasionally it's kind of nice to be able to whip up the whipped cream and, you know, so I guess we get to actually now be a little more spoiled, you know.
Yeah, the inverter makes it just like a normal household now, where before it was you had to start a generator. And now we haven't even gotten used to it all the time. I mean, we might run down and think we're going to start the generator, and we realize, oh, we got an inverter we can use.
And Lisa have an immaculate and well-finished home, and they are comfortable with their electric system as they have described. However, they are very conserving people, having no television and few large appliances, so this small system does serve them well in their mountaintop location. They have an abundance of built-in lights, and they use a ceiling fan and the small kitchen appliances that Lisa has described. Up in St. Mary's, Idaho, we visited the Pappenfuss home. This is a very well-kept middle-class American home on a paved highway with power lines passing by. And pass by they do, because Roy has built himself his own power system from the beginning. The power system features 8 solar modules here, a trace sine wave, one of the largest and most advanced inverters available today, and a battery box with quite a larger battery set than we saw in the last place, again with a hinged lid and proper venting to the outside. Back on a hill behind the house, Roy has 6 additional modules and a windmill system. The house features most modern appliances, stereo TV, console, ceiling fans, and all the large appliances, laundry, etc. of any typical American home. Refrigerator or freezer is a very specialized Sunfrost brand that uses about a quarter as much power as a conventional refrigerator freezer. By using 4 to 6 inches of insulation and placing the compressor on top instead of underneath so that heat is not generated back into the box you're trying to cool,
the Sunfrost runs on considerably less energy than any other refrigerator that's on the market today.
We moved up here in October of 1985.
Well, that's about 11, 12 years now. And you have had your own power all that time.
Right. Started out with a gas lamp.
And you're not very far from the power line, so what made that decision for you?
That Roy has always wanted to do. He's always been interested in electricity, and it's just what he has wanted to do. So we built our life around our home and how we could go with solar power.
We, at one time, we owned a motel over at Plummer. And we had quite a few of the Washington Water Power men stay with us, which was good business for us. However, seeing how wasteful those people were, the company had to furnish them a room when they were so far out of Spokane, and yet they'd come in, they'd turn all the lights on, the television on, they'd shower for a half hour in the shower, and then they'd leave and never come back. They'd drive back to Spokane. And the room would sit there with the heat wide open, and I thought that was... And then when they were short of funds as a company, why they'd raise their rates, and I decided right then and there why that was the end of it. If I could get by with, having our own system, I was going to do it. It's been really a lot of fun.
In here, because you've got a little bit of everything, washing machine, bread maker, refrigerator,
We have a microwave too, and we use it.
satellite TV.
Satellite TV.
We use everything that anybody could possibly want that I know of. We don't have a computer. I have no need for one.
And I don't know how to run one.
The best part of it is our neighbors call every once in a while and say, well, we had a power outage last night. And I say, really? We haven't had a power outage since we got your first panels here. Sometimes we didn't have much power, but we had something.
I'll tell you a story about the meter reader driving in.
Well, yes, we had quite a run-in with the power company here. They continually kept driving in looking to read the meter. I tell them, well, we don't have a meter. And they look at the house and say, you have a house like this and no power meter? You're not hooked up? I said, no. And I would show them around, show them the whole system. And I'd say, would you do me a favor? Yeah. Well, would you let them know in the office or get it on your computer or something that we don't have a meter here? And, oh yes, well, I'll do that. And the next month, well, here they come buzzing up the driveway again. And I guess they get paid by the second or something, the way they drive, tearing up the driveway and whatnot. So I finally had to have my lawyer write them a letter and tell them I was going to get them for trespassing the next time they come in. Haven't had that problem since.
The power lines cross our property to the west, just by the highway, but we didn't hook to them.
Well, they're within 300 and some feet.
Yeah, that's just...
If we can refrain from using our natural, well, I guess it's not natural, it's burning gas and stuff to produce electricity, well, it would certainly help on depleting the, so it wouldn't deplete the ozone. And I think the way things are going, why the hole seems to be getting bigger all the time, why we're getting more cancer, and also the weather seems to be turning stormier all the time, and that's just the way I feel about it. If I can add a little bit to the longevity of our world, I'll certainly do it.
When we started this tape, I posed the following questions. When does independent power cost less than getting utility power? And how far is your home site from the utility power lines? Check with your local utility, but in general, the cost of extending the power lines 1/4 to a half mile to reach your building site costs between $5,000 if the lines are built on poles to as high as $15,000 if the lines are underground. This is about the same cost as building your own independent energy system with solar electric modules. You should understand that the cost of electricity generated by solar electric equipment is greater than the cost of utility power, where the utilities are already on site or connected to the home. The amount of solar power you will have, therefore, from a solar electric system is more limited than the amount of power available from the utility company. A typical U.S. home connected to utilities uses anywhere from 10 to 100 kilowatt hours a day. Most independent solar electric homes use from 1 to 3 kilowatt hours a day. Because the power available in an independent power system is much less than a utility-connected house, and because we want to keep the costs reasonable, we do a lot of conservation design first in building a solar electric power system. The main thing is the selection of appliances. We find appliances that do the same job, no compromise in lifestyle, but use about 1/4 as much power. Lights, refrigerator, freezer, heaters that don't require a blower, and we always substitute propane gas for major electric heating items like the water heater, cook stove, and clothes dryer, as well as heating of the home. We also learn about energy conservation, not wasting any energy so that the energy is all available for our particular purposes. Phantom loads refers to appliances that draw power 24 hours a day, even when they're switched off. We disconnect them entirely from power to save that energy for more purposeful uses. And then finally, only as the last resort do we compromise a lifestyle. For instance, air conditioning is very costly to operate, although not quite impossible, on solar electric power. People usually use evaporative cooling, but in humid climates where that's not possible, many people have to go without air conditioning. Other factors to consider: with solar electric energy and valuing independence, most owners do their own maintenance, meter reading, battery checking, etc. However, there are more and more local dealers now available to help you with these chores and to help you learn what you need to do yourself. With independent power, we almost never have an outage, and there's no monthly power bills. Except for generator use, we use renewable energies, no fuel, no wastes or pollution, no noise. We are pioneering a better future for the Earth and can serve as an example to that end. Our next visit is to Jennifer and Lance Barker's home in Central Oregon, where they have quite an array of solar modules, different types accumulated over a long period of time. Lance completely built his own system, recently upgrading to the sine wave trace inverter, one of the best available today.
Did the freezer
So
come
you have
on
a
when
deep
I
well?
opened it?
Yes, we have an AC deep well pump with an inefficient Franklin motor on it, and then right now the freezer's running, so the inverter's running. Well, I chose this land because I wanted a place off of the grid, because my goal from the very beginning was to have a home and a life way that did not depend on purchased raw energy. And so it was a purposeful decision.
And how long ago was that?
I moved here in 1979, and I put the first solar panel up in 1981.
And you just worked them as you went along, so you have how many now?
I lose track, but we have about 28 or 30 various
30
panels. We've bought a few at a time. We add to it constantly. I just put a few more new ones up this winter. And we plan to continue adding to the system until it meets our maximum irrigation water needs, which may be quite some time.
How large an area do you irrigate? This is your vegetable garden?
Yeah, our vegetable garden produces all the vegetables that we eat on a year-round basis. It's kind of spread out, so it's hard to say exactly how much land area it is.
Do you know how many gallons a day you put on it?
2,000 to 3,000 gallons a day.
Really?
We live in the desert. It sometimes does not rain at all for months, so we depend, and it's entirely drip irrigated.
So you're pumping all of that out of the well?
It's 40 feet to the water, and we run a skid with a low pressure system, so that it runs at low pressure to minimize the risk.
And you've got the large Sunfrost refrigerator and the freezer and the really efficient, stable washing machine.
We quit using the
The
freezer power.
refrigerator here is full of our root cellar vegetables.
Yes.
Yeah.
Cabbages that we dug out under the snow last month.
And the top?
Oh, the top's empty because we moved all the stuff out into the vest frost.
Oh. Okay.
Here's the vest frost, full of garden produce and socially responsible ice cream. And pesto.
You have a shop with tools that you run on that?
Yeah, shop, power tools that we run down, vacuum cleaner, you know, most of the, whatever the system will really run whatever we feel is reasonable.
So the only thing that you don't have now that you would like is to be able to increase your amount of pumping. You're building for that.
Yeah, our largest energy use is to pump water, and pumping water takes a lot of energy.
Well, I also like the stereo and the computer and my sewing machine.
Jennifer uses her computer in her employment as well as publishes a country newsletter of philosophy, remedies, and technology.
This is an inkjet printer because it likes the inverter power. Actually, it liked our old modified sine wave inverter power, and it just loves the sine wave inverter power. And it only uses 18 18 watts, which this whole computer uses about, uses less than 50 watts. The computer, screen, and the printer all running together uses less than 50 watts.
Well, I think sometimes people come out here and look at our system and throw up their hands in the face of an impossible outlay of money and knowledge, but that isn't how we did it. We started with just one panel and built the system one piece at a time over a period of nearly 20 years. So the total outlay at any one time was never that great, and we learned and have a much better system that meets our needs much better than if we just bought an all-at-once fits everyone system.
And you learned about it, you know where every wire is, and that's an important thing.
Exactly. Self-reliance is, as I said, helps keep us in contact with ourselves. And if something goes wrong with something here, I call the most knowledgeable electrician around. And and if I genuinely need help with something that I cannot figure out, a phone call to you or Bob O has always answered, a problem question that I had. I've absolutely done everything myself. You had kind of brought up the idea of why we do it and how we feel about it. And for myself, I realize that we don't have or do some of the things that are considered maybe necessary in regular American life, and our culture teaches us that those are sacrifices. But we find that carefully examining the choices that we make in thinking long about it actually makes our life better for us. We are more, it helps us know who we are by examining the choices we make very carefully. So what might look to somebody else to be a sacrifice helps give our lives purpose and meaning. And it makes us happy.
Next, we visit Mark and Julia Scatred's home in Tonasket, Washington. They have 4 large solar modules, a system slightly larger than the first one we saw, but much smaller than the next 2. The batteries are in their own enclosure under the stairwell. The house is small, very well finished and well built, with gas range, wood heat, and comfortable living area. Solar power stored in the batteries is converted to 110 volt AC power by the Trace 2512 inverter with backup battery charger built in. Theirs are 2 bedrooms, including this one with a reading light for their son Jesse, and a study area. And a study area for Mark, who is active in environmental concerns.
Here in this house about 3 years, almost 4.
And when you came up, you found some distance or expense which would preclude having the power lines, I would assume.
Yeah, we're over 2 miles from the closest power, and we're about 4 miles from the closest telephone, and it was going to be, tens of thousands of dollars to bring either electricity in or the phone.
And you got pretty comfortable doing it independently.
Yeah, I didn't find there was much problem at all doing the electrical installation. And there's a lot of good books, self-help books out there, and the telephone, of course, was probably the most complicated setup, but that comes pretty much ready to go. But the electrical part was fairly simple to put in.
You have a wireless link to the telephone lines. How far away are they?
They're about 3 miles away.
And it was line of sight, you were able to get it?
We're not exactly line of sight, but we're in good enough proximity that the small hump we have to go over, the signal doesn't have any problem.
Small to medium-sized solar power system, and it seems to provide your lights, and you've probably got a TV and
Right.
kitchen appliances. And you're wired for, all of your lights are DC, or I saw the one downstairs was AC?
We've got one AC light downstairs underneath the house, but everything else is DC. Though we could be AC on anything because we've got AC available anywhere in the house as well.
You have a 2,500 watt inverter.
Correct.
So has there been any limitations or frustrations with things you weren't able to do electrically?
If I've got power tools that I'm running, I just turn on the generator and use the generator's power. But for any household use at all, we've had absolutely no restrictions with the 2,500 watt. We can run a wash machine, and when the pressure tank gets depleted, the AC pump automatically kicks on. We can run the vacuum cleaner. There's just been no limit so far on what we've been able to use in the house.
We have a stereo and 2 laptop computers we use daily.
Right, so we found that the 2,500 watt with its surge capacity has been wonderful to use. Trouble-free, totally.
And your refrigerator is propane?
It's a propane refrigerator, a full-size refrigerator for the propane-type refrigerators, and we have propane on-demand hot water, and we have a propane cook stove. So we're, as well as solar-powered, we're also propane-powered.
And a pressure water system pumped by the solar power.
Right. It's an AC half-horsepower pump, and it pressurizes an 80-gallon pressure tank, and it runs totally off of our inverter and batteries.
Now you're active environmentally too. I got a picture of your poster upstairs. Do you
find a lot of satisfaction from the fact that you're not supporting the nuclear industry by doing your own? Was that a factor in your power, or was it simply the practicality that you're so many $1,000s from the commercial lines?
It's both. One is our quality of life here is such that we wanted to live here, and as well as be in the 20th century versus the kerosene powered, etc., that I had lived before. And it is enjoyable to be off the nuclear powered grid. Washington's quite dependent on nuclear power as well as water power. And so we have chosen to be totally off the grid. We don't have a freezer down in the valley that we use, as some of our neighbors do, that is hooked into the grid. So I enjoy being nuclear free in our everyday living.
Well, we're about an hour into the tape now, so you might want to take a break and come back and finish it later. We're going to go ahead now and go through each item in our catalog, or most of them, and try to get a closer look at it than what you can get from the black and white pictures in the catalog, and get a little more information on how to select one thing comparing it to another. Starting with solar modules, we carry two major brands, and they are the major brands, Siemens and the polycrystal blue ones, which are SolarX. There are many good brands of solar modules out today, and there's some others that have come and gone with ideas that haven't been quite as good. But the ones that we carry are the very oldest and largest ones. They're made in the USA predominantly. Siemens used to be the Arco brand. It was bought out by the German company Siemens. They're still manufactured in California. The original M55 is one of their main panels, very compact and small. You can get more of them on a given type and price of mount. And the SP75, a 75 watt module that is probably our best seller, has been for about a year. These are single crystals, a single silicon crystal that's been grown and sliced, and they give a little bit more power for the area of surface exposed. They are very, very durable. They've been warranted for 10 years for a long time, and just this year, 1997, they have changed that to a 25-year warranty. They're always competing with SolarX, the brand that's made in the east coast of the U.S., which is a polycrystal, so it gives you that blue sparkly appearance that you see on these modules. A 60 watt module and a 77 watt module. The 77 watt module is slightly larger than, or quite a bit larger than, the 75 watt Siemens in surface area, because the polycrystal requires a little bit larger area. They all seem to be just as stable. That's why they're warranted for 20 or 25 years. These things are not going to give you any trouble, and if they do, those companies are very likely to be there and will replace any that have problems. Occasionally, one out of several thousand will get a bad solder joint that opens up between two cells and cuts the power down or off, and that's very rare, but in those cases they've been exchanged with no problem at all for a new unit. The main difference that people notice with these modules is that the Siemens modules have a white background, which actually keeps them a little cooler, and these things put out a little bit more power when they're cool than when they're extremely hot. And they have an anodized aluminum frame, which is very durable. The SolarX module has a blue backing, which shows through between the cells, unlike the white checkerboard or polka dot pattern on the Siemens, and it has a black anodized frame. So when a lot of these are put together on one rack, like the ones you see on the cover of our house right in the center of the porch roof, it looks much more uniform and smooth than does the individual cells. So for appearance, some people choose SolarX. But for at this moment, and they're always trying to do a little better on each one, for this moment, the SolarX, the Siemens warranty is the longest, although they're just about the same. And this is the best seller because it's a little bit lower price for the same power. But those things change from year to year, so just study that carefully in the catalog. Looking at the back of the modules, most of them have a fairly similar junction box with screw terminals in here clearly marked for the plus wire and for the minus wire to make your connections from one module to the next. For 24 volts, you use pairs of two identical modules in series to make up 24, so you just buy them in pairs. The M55, the old original industrial workhorse module that Siemens puts out, has a slightly different arrangement. With the junction box, they have a minus at one end and a plus at the other end. So you can wire them a little differently. In fact, you don't need the wires with terminals on them for the screws. You just poke it in and tighten down a clamp that they have that grabs the wire. All of the others, unlike that have the screw terminals, also have some knockout holes in the side of the box for bringing the wire out, and they have a cap that goes on to weather-tight seal the box when you're finished. To make the connections in this box, you simply insert a wire through the holes and the positive one under the positive screw, negative under the negative screw, and go on to the next module. For a more professional application that complies with wiring codes, they have fittings that will seal the connection where the wire enters the box watertight, and when the cover is put on, you have a completely sealed connection. There's also conduit available that you can insert your own wires into. No matter what kind of mount, yard mount or roof mount or whatever you select to mount your modules on, they all connect in pretty much the same way to the rails of that mount. You place the rail across the module, take a 1/4-inch bolt, and it comes out from inside the module, and you put the nut on the outside. That's the easiest way to put these together. You do that on each side, and the modules generally line up with their longest sides against each other. They would be more modules, all of the same type and shape, if you want them to fit properly on any of these mounts. Notice, however, in some cases the mount rail will cover the junction box, making it difficult or impossible to put the lid on and to do the wires or to check and service the wires later. Just about every module contains an optional set of mounting holes below the original ones, so that you can place your mounting rails down at this level, the 1/3 and the 2/3 level, staying away from the end where the junction box is. The only exception to this kind of mounting is on the VLX series, which is presently being made by SolarX. Has exactly the same cells, this polycrystal blue sparkly cell, but on the back side the frames are not as heavy. They're much lighter, and as a result the module is a lower priced module, comparable to the lower priced one of the SolarX. In this case, you use a 5/16 inch bolt. The head of the bolt slides into the rail on the frame, and you put your rail across there and attach it. It's even possible to mount them from the outside. You have another track in this frame, but I haven't found any application for that. And this one, of course, you can place the rail anywhere that you need to along the length of it, and again you have to avoid the junction box, which sticks out deeper than the frame depth, and you couldn't put a rail across that point. Moving on to solar mounts, the aluminum you see here is a rack that we make for roof or wall mounting of 3 modules in a row. It's 1.5 by 1.5 by 1/8 aluminum. Comes with a set of assembly instructions, and it is drilled out to fit any of the modules we've talked about here. We also supply the mounting hardware to attach the modules to the mount. The mounts have adjustable feet at each corner to attach to the roof and allow the angle to be set to match the roof and the angle that the panels are to be set at. Fully assembled, the unit looks about like this. It's kind of an easel that holds only the top module shown here. 2 more will fit below it. And this is in the winter position, set up high to shed snow. Of course, that depends on the angle also of the roof. We have it here on a flat floor. It will also hang on the side of a vertical wall and makes the same adjustments. This is the setting for an intermediate angle for this mount. And this would be the summer position. It can also be set to one lower slot on the back rail for more horizontal mounting, but that would depend entirely on the angle of the roof, whether you use the medium, upper, or lower holes on the back legs. Power about 30% in summer, but much less in winter. In fact, so much less that in the northern half of the United States, they are not effective in winter, and that's when most home power systems are short of power. These are useful in the southern part of the U.S. and beyond, particularly where irrigation water or refrigeration is the main purpose. They do increase the power in the summertime when those applications are most needed. In the north, however, spending the money that these would cost on additional modules is more effective for the actual needs. Looking back at our original power system diagram, we've looked at the solar modules and their mounts and the wiring. Now let's look at the charge control and meter part of the system. Starting at the small end, for many years Backwoods Solar has sold the SCI Mark III charge control and the heliotrope CC20, which is now called the CC30. These two charge controls were manufactured for recreational vehicle use, but they're very appropriate to small homes, small cabins that don't have to meet the National Electric Code wiring standards. The Mark III is for up to 15 amps of solar charging. It contains a voltmeter with a color-coded scale and an amp meter to show the amount of charge coming in from the module. So you have everything you need here to confirm the operation and check on the progress of the charge. Also has a fuse built in, automotive type fuse that protects the solar wiring from battery power in the event of a wiring problem. And a light that goes off when the charge is getting complete. When it's gotten up to 14.4 volts, it will disconnect the charge, the battery voltage will then fall, and it will reconnect at about 12.8, and it continues that cycle to avoid overcharging the battery. It's a rather simple meter with very few components and a low price. It offers either a cutout for flush mounting in your own panel or a box to surface mount on a wall without any modification to the wall surface. The CC30 is a much more sophisticated control, having a digital meter which will select with a switch to show you the battery voltage or the charge current, which is much more accurate than the other meters, but a little bit more difficult to interpret at a glance. It is much more complicated and has the constant voltage source method of charging rather than cycling on and off. It lets the voltage rise to whatever you have set and holds it there by tapering off the charge current to keep that high voltage continuously. So it's a more effective charger, and that voltage is user selectable by this series of switches. A chart here showing you how to program the switches. The Mark III does not have adjustable voltage. Mark III is good for 12 volt systems only, as most small systems are, but the CC30 can be switched for either 12 or 24 volt system. 30 amps in a 24 volt system is a fairly large, reasonable sized power system. Either of these charge controls, the method of attaching the wires to them is simply to splice it onto some existing wire stubs that comes from the circuit board on the unit. At this type of charge control, Backwoods Solar recommends a terminal block that we sell on the same page with these two controls. They allow you to put the wires in the top and tighten the screw down to make connection, and then the wires that correspond to each of these going to the battery and to the solar panels poke in the bottom of the same slot, and another screw is tightened down, and that way you splice them together without having to solder or tape them. In addition, this terminal block can be screwed to the wall, and it supports those heavy wires that are going to the solar panels and to the battery so that they do not pull on the circuit board connections of the control panel. The splice can also be put inside the cabinet for these so that the wiring is invisible, but it still does the splicing and support for all of these wires. Another charge control for very small systems is the Trace C12. This is a very specialized charge control that does a good constant voltage charge for up to 12 amps, but it also contains a night light control for anchor lights on boats, sign lighting, and other small lights that come on at dark and remain on for a certain number of hours that you can program. It will also disconnect the lights if the battery becomes too far discharged. The C12 is in a outdoor type enclosure, and inside contains adjustment for the charge control battery voltage setting, low voltage disconnect and reconnect, and the timing for the automatic control of the lights. The terminals in here are on their own terminal block with screws so that you poke a wire in here and tighten the screw down. No external block is necessary, as with the Mark III and the CC30. The C12 contains no meters, but it does have a flashing LED. It gives a series of 5 rapid green flashes and a pause, and 5 more and a pause when the battery is high voltage, 4 for a lower voltage, 3 for a less high voltage, finally down to single flashes, and then it turns red and goes into increasing numbers of red flashes for a lower voltage. So as a very simple control where precise information isn't needed, it does give you the information about your battery voltage. It does not show the amount of charge current coming in from the solar modules. Backwoods Solar also makes a 30 amp charge control with large amp and voltmeters. Again, our emphasis on user education and participation. It's easy to see what's happening with this one, and it has manual control on the front to bypass it should anything go wrong, lightning strike or whatever. You can turn off or force on the charge control even if the automatic part should fail to operate. All the components inside this one are modular and replaceable by the user. The control made at Backwoods will probably be discontinued in future years because of new, superior controls available at no more cost. Even without the optional meter, the C40 contains that same light that the C12 had. You can see it blinking 4 times on the left side there now. 1, 2, 3, 4, to indicate the battery voltage is nearly up to the maximum. But this one has the optional meter panel on it, which is very valuable in showing you exactly what's happening with the system. It shows you the amount of solar charge coming in on the left, which on this demonstration is 0. It shows you the battery voltage over to the right side, which is 28. And it shows you the totalizing amp hours. That's a very unique function which counts up the amount of amp hours that has been received over the life of the charge control. This one here being resettable. When you push this button, it resets to 0. Each day when you come home, you will see how many amp hours charge has come into the battery during that day, and you can reset it to 0 at any time. Although this control is available without the panel meter, we recommend that it be used with the meter option. Inside the CC40 are large terminals that will accept up to 4-gauge copper wire directly without any external terminal strip for your battery and for your solar modules. Adjustments for the charge voltage as well as for a float voltage. This control will drop back to a slightly lower float voltage that you can set if the batteries are not used for a long period of time. So if you go on vacation, you don't have to set it to a lower level to conserve water consumption in the batteries. It does that automatically. It will also equalize the batteries automatically once a month at your option if you select that, which means if the batteries become excessively low or if 30 days have elapsed since the last equalization, it gives a couple of hours of higher voltage charge as at least a partial automatic equalization. There's also a place to plug in an optional temperature compensation probe, which gives a higher charge voltage when your batteries are very cold and lower in the summer to save, again, excessive water use. All automatic. This charge control is designed for and particularly suitable to mount on top of the trace breaker box and power system kit that we will describe later. The next step up in size of charge controls at Backwoods Solar is the heliotrope CC60 and one just like it, CC120. The CC60 handles up to 60 amps of solar, but with no headroom. 60 amps is the maximum, unlike the Trace C40. And the CC120 will handle up to 120 amps of solar charging, all in one control. Again, that would be the maximum. It includes a digital meter that shows battery voltage as well as the number of amps coming in from the solar modules, selected by a manual switch. It also has another switch for equalization and for off. Off simply defeats the control, stops the charge. Automatic is normal charge control, and equalization, unlike the trace unit, simply bypasses the control, connecting the panel straight through, and you must remember to turn it back to automatic before excessive overcharge occurs. Again, we select controls for the fact that they have a meter, and they also have terminals, everything you need to make the connection. The CC60 has particularly large terminals that accept about as large a wire as you would bring in from the solar array, so there's no need for external junction blocks to convert huge cables down to small. You can see the size that's available here. Another point, with all these integrated circuits and computer-like circuit boards in here, we were at first concerned for lightning damage possibilities. But in all of these electronic controls that we've shown you, there's been very, very little experience of any kind of damage from lightning or surges of electricity. So these are very reliable units that we've selected to sell. Being primarily mail order, that's a very strong point. We don't want things coming back and having to ship them back and forth and send replacements. So all of the things that we are selling now, except where noted in the catalog, are very reliable and selected over years of experience with the product. This ends our look at individual charge controls. There are a couple of others in the catalog, the TDR and the Enermaxer, which are diversion controls, mostly associated with hydro and wind power systems or systems with combination. We won't go into those in this tape except to mention that the C40 control can also function as a diversion control, so you have those three choices if wind or hydro is part of your system. And I'd like to add a reminder that if you use this low-cost approach of an individual charge control, making up your own system, you will need to add a fuse between the charge control and the battery. A DC fuse like this will not pass building codes unless it's enclosed in a metal enclosure. But this is your safety component that is essential to have on everything connected to the battery. There is an easier way to go than building your system from separate components, and that is to use a power center. Power centers include the charge control, advanced metering devices, the main fuse for your power inverter, fuses for your solar inputs, as well as for breakers for additional DC outputs. Those flashing battery condition lights that we saw in some of the charge controls, and all the terminals and hardware that you need already pre-assembled in one box, which is UL listed, approved to pass the national building codes. Very easy way to get started. Where the battery cables, inverter cables, solar panels go are all labeled with stickers. There's an instruction book, and all the hardware and parts that you could possibly want with it come with the device. There are several companies that make these, and with so much in one box, there's lots of options and things you can specify how you want them. We've tried to simplify it, because most people who buy this do it because they don't want to plan out the system in great detail and study it. They want to have something that's ready to go and pre-made. So in our catalog, we have selected one model of this unit, one or two models, with everything pre-installed in there the way most of our customers would want to have it. And we also list a series of about 6 options that are the most popular options you might want to add to customize it just a little bit. But this is the easy way to go with everything set up for you already. Of course, with all that factory installed equipment in one UL listed box, the price is a little bit higher. So there is an intermediate way to go and still gain most of the benefits of a power center. The Trace Inverter Company makes a DC breaker disconnect to protect power between the battery and their inverter. But they've also designed this box so that it can be built into a power center with all the functions on the one I just showed you for a much lower price. This is a neatly constructed power system. using the trace sine wave inverter, its conduit box attachment, which joins it right to the side of the trace breaker box. The trace breaker box has smaller DC breakers in it and a main breaker for the inverter. And a charge control bonded to the top of it controls the solar charge to the battery. So a whole power center here has been built using several lower cost components to function as well as a complete factory prefab power center. Backwoods Solar sells this box completely as a kit with all hardware and instructions available. Assembly requires removing some knockout holes to install hardware for inserting wires in and out of the box. And after a few more parts are installed, the finished box looks like this. It requires a screwdriver, pliers, a few wrenches, and average mechanical aptitude to put together. Well, that pretty much wraps up everything in the system control and charging end, except for the accessory meters, the trimetric meter and the Vista 3 meter. And I will not go into detail now on the differences between these. It's much easier to digest looking at it in the catalog. This is a meter that shows how much power is coming in, how much power you're consuming, and your battery voltage. This does the same thing, except that it tries to keep track of how much fuel, how much energy is left in your batteries. Much more difficult to set up and get it reading correctly with your batteries, but it gives you an awful lot more information about the condition of your batteries. So take a look at that in the catalog with the descriptions. We also have a separate literature and instruction book you can ask for on this meter that fully explains it. So with that, we've covered the basics of the charging and control systems. It brings us right down to a very important item in the system, and that is the batteries. For the typical residential solar power system, we recommend typical wet cell lead-acid batteries as the most reliable component you can use today. There's many variations of types of batteries, but these are the ones we've had the most success with. This is a small golf cart battery. They come in 6-volt configuration. 3 2-volt cells makes 6 volts. We use 2 of them together to make 12 volts or 4 to make 24 volts. And then we add more pairs to that to increase the storage. But before you get to too many pairs, to a very large system, we would rather go to a larger battery, the Trojan L16, which is an industrial battery, much heavier, actually 120 pounds. And the life of this battery is longer than the life of a golf cart battery. The small batteries typically last 5 years, the large ones 8 to 10 years, sometimes more. We found the Trojan brand of golf cart battery to be almost completely without defect, trouble-free, but batteries are probably the part of the system that we spend the most time trying to educate customers about, because they are the most difficult part to properly care for. In fact, the only part that takes any care or maintenance in a solar electric system. With lead-acid batteries, you probably have heard before, it's very important to keep them charged completely full, not overcharged excessively, but certainly charged full on a regular basis. If these batteries are discharged, power is used from them, and it's not completely filled back up again, they will deteriorate faster than they should. So it's important to have enough solar modules to use your generator when necessary in bad weather with no charging, so that these do get completely charged at least twice a month, preferably once a week. And kept like a gas tank in a car, running from full to half, full maybe to 1/4, then always back to full. Never running it down to empty, filling it 1/4, down to empty again, filling it to a half, down to empty like you might do with a car gas tank if you're short on money. That will deteriorate and shorten the life of a battery. It's very important on lead-acid batteries to keep them charged full. Now these particular batteries are called deep cycle batteries. That means you can use them. You can take them down 85%, and then you can, but you need to charge them 100% when you return them. How do you tell how far up or down they are? Those meters that we just talked about can give you some indication, but the most reliable and in fact the cheapest way to tell what state of charge your batteries are in is to use a hydrometer. Now anytime you go to open the battery and fool around with the acid or make connections to the battery, it's a good idea to put goggles on. The acid in there isn't terribly strong. It takes all day to make holes in your clothes. You won't know it till the next day. If it gets on your skin, it irritates it, but it's not an immediate emergency. However, if even a drop of it splashes in your eye, it will blind you in a very short time, and it is an emergency, and you need to run water in your eye immediately and get medical attention. Best to put goggles on in case it splashes out. Just using this thing, it's very easy for some people to flip the tip around and be careless with acid. Best to put it in there, not take it out until you're finished measuring. What happens here is we draw a little bit of the acid up into the tube here, enough to make this float rise and float in the acid, but not enough to make it hit top, enough to lift it off the bottom, so it's freely floating, not sticking to the sides. Then we notice what part of the float is at the surface level of the water. When a battery is fully charged, the water is thicker. It's got more acid in it. It's heavier. It's like the water in the salt lake, where you float higher in the salt lake than you do in fresh water. This floats higher on a charged battery than it does in a discharged battery, which has weaker acid. So, in this case, it picks it up when the water gets up this high, and the green area is where the surface of the water is as the float floats freely in the top of the water. If this battery were discharged, it wouldn't pick up that float at all, or it would wait at least until it got up into some portion of the red, which would indicate to you what the charge level of the battery is. Now, we were careful to put every dropper as much as possible right back in the same cell before taking this thing out. Don't take it out and wave it around when it's full of liquid, like some people do, because that's dripping, spilling, losing what's supposed to be in the battery, also getting it onto your clothing or other parts of the house where it doesn't belong. The safest way to store the hydrometer is with the bulb inserted between two screws or nails in the wall, and the tip stuck into a jar to catch any drips and to prevent it from being curled over, as would happen if you just dropped it completely into the jar. It should be suspended on the wall with the jar below to catch any drips. At Backwoods Solar, we use 12 of the L16 industrial batteries. When you purchase batteries here, all the wires connecting the cells together come with them, as well as the battery book and a hydrometer. The next item following batteries is a DC fuse or circuit breaker box, a way to connect 12 volt or 24 volt circuits to the battery safely and conveniently. If you were to build your own, you would probably use a fuse terminal like this, where the tops of 5 fuses are all joined together. It would be connected to the battery, and on the bottom you can connect DC 12 volt televisions, lights, and even your solar panel inputs to the battery, each on its own fuse. This would be for very small, simple systems in a cabin or on a boat. At Backwoods Solar, we make a ready-made fuse box for that type of purpose in a small cabin. Has a main disconnect switch to shut everything off when you leave, a meter to show how much power is being consumed, and inside are 10 of those fuses for connecting to your television, lights, and other circuits for small 12-volt DC systems. And now we're almost to the last item on the chart, the inverter, a device that changes the DC stored in the batteries to AC household power, so you can use your computer, vacuum cleaner, power tools, and other common household items. Inverters are available in a wide range of sizes, from these small portable units made to be used in an automobile where you would plug in to recharge a video camera or a portable computer, all the way up to the larger units to permanently install in a home and feed power into the wiring system to your outlets and appliances. The choice in size would depend perhaps partly on your budget, but mainly on how large an appliance do you need to run. Do you have a wood shop with a table saw? Do you have a washing machine in the house? Or is it a small cabin with a television, stereo, maybe a vacuum cleaner, but nothing larger than that? We recommend trace inverters as most suitable to home power applications. Trace inverters are available in 3 ranges: the small 800 watt inverter with or without a built-in battery charger, for small cabins and homes that have stereo, television, power tools, vacuum cleaners, but no large high surge appliances like a washing machine. The DR series inverters in several different model sizes for equipment larger than that, including washing machines and large power tools. And the sine wave series of inverter, which has automation, computer-driven ability to start and stop your generator as needed to supplement charge on the batteries. It can interconnect with utility or generator power. Quite a lot of features. For the details of each of these, it's best to look in the catalog and some of the books that are shown in our catalog. Things about the waveform and power of AC sine waves and square waves and so on. I'll try to sum it up pretty simply. The power company and a generator makes what's called a sine wave. That just means the AC power moves smoothly to a positive voltage, then to a negative voltage, then to a positive voltage, and so on. For reasons of economy and efficiency, inverters make a square wave. It goes suddenly to a positive voltage, suddenly shuts down to zero, suddenly to a negative voltage, suddenly to zero again, suddenly to a positive voltage. In most cases, this type of power works just as well as the sine wave, but in a few cases there are some disadvantages. This square wave is often called a modified sine wave by the promoters of the inverters that make a square wave and don't want it to sound like one. It does not work with a very few appliances, and those appliances of particular concern are the rechargers for portable battery operated tools. Do not plug this type of recharger, DeWalt, Makita, whatever, into a modified sine wave inverter. It will destroy the charger immediately in most cases. Chargers that use the little transformer plug-in cord rather than a direct plug-in will usually work, but I can't guarantee it in every case. The best solution for recharging these rechargeable tools, if you don't have a sine wave inverter, is to get the 12-volt charger that's made for plugging into an automobile. DeWalt and several other companies make this, and it'll recharge batteries from 7 volts up to about 14 directly from a 12-volt connection. Completely safe and very versatile and useful. Other items that should not be used on a non-sine wave inverter, on a modified sine wave inverter, are photocopy machines and most laser printers, although Trace lists several Texas Instrument laser printers that should work okay. Some Apple computers will not work but won't be damaged on a non-sine wave inverter. All other computers, inkjet printers, dot matrix printers, there should be no problem whatsoever running them. Sewing machine speed controls and light dimmers may work or may be a little bit erratic on a non-sine wave inverter. Aside from those exceptions I've just mentioned, you should be able to run any other item within the power rating of the inverter on a standard modified sine wave inverter. If you want no exceptions whatsoever, you want the very best of everything, consider the sine wave inverter, because the power that comes from that is exactly the same as from the power company or from your generator, actually more stable than it would be from a generator, so it's a lot safer for computers. And when you've installed this, you can use anything without consulting the manuals to see if it's safe or not. Most of these inverters have a battery charger built in that will automatically charge the battery as soon as you start the generator. If you don't have that type of inverter, you can use an automotive type charger to charge the battery when you run your generator. You just have to manually start and stop it. Throughout this tape, I've stressed the importance of using appliances that give us the same job, do the same job, same services, and use much less power. And that way, the limited amount of power that we have on a solar electric system goes a lot further. Elizabeth is going to show some of those appliances.
This is an AC compact fluorescent bulb. In this case, it's a 20-watt one that will give you the same light as a 75-watt incandescent bulb. And it takes 1/4 of the power. That means you can go 4 times as long with this light bulb on the same amount of power, or maybe have 4 light bulbs for the same amount of power that you would get from one incandescent bulb. Bulbs come in all kinds of different sizes and configurations, as you can see, and we have them in the catalog. DC compact fluorescent lights are also available. However, they cost a little bit more, and they're not always as reliable as AC lights. So we usually recommend that people wire their house for AC lighting. Because DC lights are a little difficult to find, we do carry quite a selection, including the compact fluorescents and fluorescent and quartz halogen lighting. One of the most important things in independent homes is to have a freezer and a refrigerator that are super efficient. This Vest Frost here takes about 1/4 of the power that a normal freezer would take. It's a nice size, about 7.5 cubic feet, and you can see one of the reasons that it's so efficient is it has this 4 inches of insulation here.
Sunfrost is another brand of refrigerators made especially for solar electric homes. Make a variety of models, all super insulated, and available in 12 volt, 24 volt, or 110 volt AC.
For those people who don't want quite such an expensive refrigerator, want to pay a little bit less and don't mind a smaller one, the RV marine refrigerators work well. This has got a nice refrigerator part and a pretty good freezer. You do need to add insulation to this type. About 2 inches of added insulation will make quite a difference in the performance. The added insulation to this refrigerator will cut the power consumption in half. This is a NovaCool 7500. It's the newest model they have come out with. For deep well pumping, if you have a large solar system, you can use an AC submersible pump. They are 1/3 horsepower to 1/2 horsepower, use a lot of power, and must have a 2500 or larger inverter at 110 volts. You'll want to avoid any pumps that are larger than 1/2 horsepower and any pumps that are 220 volt. The 1/2 horsepower pumps will go down to 300 feet.
The deep well water pumping for smaller power systems is a DC powered submersible pump, which will work off your battery power at 12 volts. It'll work twice as fast at 24 volts, or it'll work directly from a solar panel if there's no power system nearby. This pump pumps very slowly and requires more maintenance and costs a little more than the AC pump, but it brings out a lot more water using a lot less power compared to any other type of pump.
There's a new generation of washing machines that take 1/4 of the power of the water and the soap that the agitator type took. This is one of the new ones. This is the Staver. It's top loading. This washer loads from the top into a rotating horizontally drum like a dryer. It can run on as small an inverter as 800. It takes very little power, and especially if you're doing a lot of loads of laundry a week, it is very important to get a very efficient washer.
This Staver washer, as well as peerless stoves and other hard-to-find energy-saving appliances, will be shown in our catalog. Backwoods Solar is still a small, home-based business, although now we have 2 almost full-time employees, and we take as many calls and ship almost as many orders as we can handle in a day. J.D. Colwell takes your calls and letters, writes orders, and answers your questions on the phone every day. Scott Gentleman packs 10 to 40 orders each day, maintains the shipping and receiving records, and gets everything to the UPS truck on time. Elizabeth and I spend most of our time answering mail and phone inquiries and meeting customers who come up to our showroom. We help people solve their problems with equipment and plan their design of their house and electrical system. Most of our business is mail order. We now take Visa, MasterCard, Discover, and American Express for telephone or mail orders of this equipment. We have an electronic shop and a mechanical shop for operation and testing of equipment used in home electric power systems. So we use this equipment every day to run our own home and our own business, and we become very familiar with the best designs to recommend to our customers through the experience of it in our daily lives. There are no power lines still within 2 miles of our location.